Hi friends, in this video we are going to find the equivalent inductance in this problem. Okay, now we know that if you know about how to calculate the value of equivalent inductance when inductance are connected in series, and how to calculate the total inductance or equivalent inductance when inductors are connected in parallel. If you know about this condition or calculation, then only it is possible to calculate the value of total inductance in this problem. Okay, now see here, the question is find the equivalent inductance across the terminal A and B. Okay, so this is the question and this is the network he given. Now see, this is the terminal A and this is the terminal B, and the question is find the total equivalent inductance. Okay, so find the total equivalent inductance across the terminal A and B. Okay, now we know that the most important point we need to follow here is when terminals are connected in the right side of the network means always we need to start reduce the network from left side. For example, if the terminals are available in the left side means always we need to start from right side. Okay, so not only for inductances, this concept or this procedure is same for calculation of equivalent resistance, calculation of equivalent capacitance, calculation of equivalent inductance. Okay, so this is the most important point we need to proceed to calculate the value of equivalent inductance or resistance or capacitance. Most of the students what they will do here, terminal A and terminal B is connected here means they will start from here. Okay, now L8 and L7 both are connected in series. They are thinking that these two are connected in series, but we know that when inductors are connected in series means there is no disturbance between the two inductors. Now see here, L8 and L7 both are connected in series. When it is possible, when there is no value of inductance is connected between at this point. Okay, if there is no connection of L5 here, then the L8 and L7 both are connected in series. So that is the reason why so many of the students are doing mistakes with the because of this confusion. So that is the reason why what I am telling you, if the terminals are in the left side means always we need to start reducing from the terminals are in the right side means always we need to start reducing from left side. For example, if these terminals are available in the left side means always we need to start reducing from right side. Okay, so now see, now in this problem terminal A and terminal B are available in the right side. That's why what I am doing, I am starting reducing the inductance or calculation of inductance starting from left side. Now see, for example, assume this is 1 point and this is 1 point. Okay, now this is 1 point and this is 1 point. Now see, between these 2 points I am talking about only this branch. Okay, so between this point and this point, L1, L2, L3 all are connected in series. Just see here, L1, L2, L3 all are connected in series. So that is the reason why first we need to get the equivalent inductance for this series combination of L1, L2 and L3. Now after getting the resultant of series combination of these, then we need to replace the resultant value given by the series combination again in the network. Like this we need to proceed to find the total inductance across the terminal A and B. Okay, now see here, step number 1. So step number 1 is, now L1, L2 and L3 inductances are connected in what? In series. So all are connected, L1, L2, L3 all are connected in series. Now we know that when inductances are connected in series, to find the equivalent of this series connection, we can directly add all those values which are connected in the series. So total inductance is equal to L1 plus L2 plus L3. Now here the value of L1 is 1 Henry and the unit of inductance is always Henries. Okay, the value of L1 is 1 Henry and the value of L2 is 2 Henries and the value of L3 is how much? 3 Henries. Now here the total inductance is equal to 1 plus 2, 3, 3 plus 3, 6. So the resultant we are getting for the series combination of L1, L2, L3 is 6 Henries. Okay, 6 Henries. Now what I am doing here, I am replacing this particular resultant inductance in what? In case of the series combination of L1, L2, L3. And we know that in the given problem, total 9 inductances are connected. Now what I am doing, whatever the resultant we are getting for the series combination of L1, L2, L3, I am giving the name for the new inductance, that is L10. Okay, so L10 is the new value of inductance, and which is the combination of, which is the resultant of what? Combination of L1, L2 and L3. Now here L10 is equal to 6 Henries. Okay, so L10 is equal to 6 Henries. Now what I am doing here, now replacing this L10 is equal to 6 Henries in the actual network. Okay, now see here. So here, for example, this is terminal A, and for example this is terminal B. Now see here, this one is what? So L8 is connected here, and here L9 is connected. So this one is what? L9. And here, between here, so another inductance is connected. This is what? L7. Now after this one inductor is connected. This is what? L5. And here one more inductor is connected here. That is what? L6. Now here the another inductor is connected here. This is L4. Now coming to the replacement of L10 in the actual network. Now see, the resultant of these three inductors, we got the value is how much? L10 is equal to 6 Henries. Now I am placing this resultant value, that is L10, instead of the series combination of L1, L2 and L3, like this. Now this is how much? L10. Okay. Now see, the value of L10 is how much now? 6 Henries. Now here the value of L10 is equal to 6 Henries. Now here the value of L4, the value of L4 is equal to 4 Henries. Now coming to the another step, that is step number 2. Now coming to the step number 2, here see, if for example assume this is 1 point, and for example assume this is 1 point. From this point to this point, L10, L4 both are connected like what? Parallel combination. Just see here, these two are connected in parallel. Now we know that when two inductors are connected in parallel, to get the value of resultant of this combination, we can directly take the value of the formula is what? The total inductance. And here L10 is the last new inductor. We got the combination of what? All these L1, L2 and L3. Now L10 is already over. Now what I am taking, I am giving the name for the parallel combination of this new inductance is L11. So L11 is equal to, so we know that when two inductors are connected in parallel, we can directly use the formula, that is, so product of two inductors divided by addition of two inductors. So that is the reason why L4 into L10 divided by L4 plus L10. Okay. Now here L11 is equal to, the value of L4 is how much? L4 is 4 Henries. The value of L10 is how much? L10 is here 6 Henries divided by the value of L4 is 4 plus the value of L10 is 6. Here, so here how much? 24 divided by 10. Okay. So L11 is equal to 24 divided by 10 means 0.24 Henries. Okay. So this is the value of new inductance when we are going to finding the parallel combination of L4 and L10. Okay. Now L11 is the parallel combination of this one. Now what I am doing, I am going to placing this L11 instead of the parallel combination of L4 and L10. Now see here, I am placing this value in the actual network again. Now see here, So for example, this is the terminal A, and for example this is the terminal B, and here one inductor is connected like this and one inductor is connected like this. I am just drawing the previous network only. Okay, so this network again I am drawing, and instead of this parallel combination I am going to placing this particular L11 value. Okay, so that is the reason why what I am doing, just I am just placing here. Okay, whatever the network is there, I am just redrawing here. So just see here. Yes, now next is what? L5, L6. This is L5, this one is L6, and here coming to this point, so the combination of L4, L10, we got the value of L11. Now I am placing this particular value instead of the parallel combination of these two. That's why, just see here, just sorry here, just see here, I am drawing this L11 instead of the parallel combination of L4 and L10. Okay, so like this, what we are doing, instead of this one we are just drawing like this. Okay, now see here, what is the next step here? What is the next step? Now we need to find again here. Now see, for example, we are considering this is 1 point and this is 1 point. Now see, from this point to this point, this three are connected in parallel. Yes or no? Just see here, sorry, in series. So from this point to this point, L5, L11, L6 are connected in series. Now how to get the series combination of resultant value? Now we can directly take, so total inductance, or we can also call it as L11 is the last value, that's why I am taking L12 is equal to L5 plus L11 plus L6. Okay, now we know that L5 value is 5 henries, L4 value is 0.24 henries, the value of L6 is 6 henries. Now here 5 plus 6, how much? 11. 11 plus 0.24 means 11.24 henries. This is the new value of inductance when we are going to finding the series combination of these three inductances. Okay, now this is clear. Now what I am doing, again I am going to redrawing this network. Instead of the series combination of L5, L6 and L11, I am just placing this L12 here. Okay, now see here, again this is terminal A and this is terminal B, and here inductor is connected, that is L8, and here inductor is connected, this one is L9, and here one inductor is connected here, this is L7. Now what I am doing, instead of this series combination of L6, L5, L11, now we got the resultant of that series connection, L12 is equal to 11.24. So that's why what I am doing, instead of this combination, so I am going to replacing the L12, that is the resultant given by the series combination of L5, L6, L11. Okay, now this one L12 is equal to 11.24 henries. Okay, now see here, now just observe this network. So L8 is equal to 8 henries, L7 is equal to 7 henries, L9 is equal to 9 henries, and this one L12 is equal to 11.24 henries. Now see here, again here, for example, we are assuming this is one node, and for example this is one node. Now L11, L12 both are connected again in parallel. Yes or no? Just see here, just see here. So L11 and L12 and L7 all are connected. These two are connected in what? In parallel. Now see here, this combination is connected in parallel. Now here we are going to find the parallel combination of these two inductances. Now L12 is the last new inductance. Now I am taking L13 is equal to, when inductors are connected in parallel, we can directly take what? The product of two inductances divided by addition of two inductances. That is what? L7 into L12 divided by L7 plus L12. That is equal to L7. L7 is how much? 7 into L12 is how much? 11 into 24. Divide 11.24 divided by 7 plus 11.24. Okay. Now this one L13 is equal to 7 into 11.24 divided by 7 plus 11.24. Now L3 is equal to 7 into 11.24 divided by 7 plus 11.24. Now by solving this total value, now you will get L13 is equal to 4.3135 henries. Okay. So by solving, you will get the value of new inductance, that is L13 is equal to 4.3135 henries. Okay. Now this is the resultant of inductance when we are going to finding the parallel combination of L7 and L12. Now what I am doing, I am going to place this L13 instead of this parallel combination. Now here the network again becomes so like this. So terminal A and terminal B. Here this one is L8. So L8 is equal to 8 henries, and here L9 is equal to 9 henries, and here the parallel combination of these L7 and L12, we got the value L13 is equal to 4.3135. Now I am substituting this value or replacing this value instead of the parallel combination of L7 and L12. So that is L13 is equal to 4.3135 henries. Clear? Now here, what is our target actually? We need to find the total inductance across the terminal A and B. Okay. Now just observe here. Across the terminal A and B, L8, L13, L9 are connected, and all these inductors are connected in series. So that is the reason why the final inductance or total inductance across the terminal A and B. So the total inductance across the terminal A and B is equal to L8 plus L13 plus L9. That is equal to L8 is 8 Henry, L13 is 4.3135 henries plus the value of L9 is 9 henries. So by simplifying you will get, so 9 plus 8, 17, 17 plus 4, 21, it means 21.3135 henries. So this is the value of total inductance across the terminal A and B for the given network. Okay, so this is the procedure we need to follow whenever we are going to finding the equivalent inductance for the given problem. Okay, so thank you so much for watching, and please do subscribe my channel for more updates. Thank you so much.